All right, welcome back to our welcome to our first set of April Math Homeschool Connection Nights. Beautiful evening out there. I apologize that I had to bring you in for an hour, but hope you get some time afterwards to enjoy the nice weather. Those of you who are watching at home, and a lot of your students told me that you'd be watching at home, make sure that you comment in the comment box so I know that you're watching, and I might allow your students to join us for Netflix tomorrow at lunch. So tonight's topics are going to be decimals, which were introduced in the first advisory. So this is more, this is stuff that the students have already had the exposure to. We're constantly reviewing it, but this is stuff that we did in math before we started the Homeschool Connection Nights. And also at the end, we'll go through a benchmark preview. Obviously, I just can't show you specific questions, but I can tell you what topics are on the benchmark and try to field any questions other than what is the answer to number 7. So as usual, help you guide in reviewing math tests, preparing your students for future tests, SOL. Tonight's going to be really helpful in knowing exactly what is going to be on the benchmark so you can really use the next week to help prepare your students for the benchmark. As always, feel free to take notes. Presentation is available on my website, and also the YouTube video is always available. So if I move a little fast and you want to go back and revisit, you can always watch the YouTube video, and everything I do on the screen shows up on the YouTube video. We'll be going over concepts and test questions in general. If you have a specific question about your child, feel free to see me afterwards, shoot me an email, class messenger, whatever. So first topic is going to be decimals, which this was, like I said before, this was our second topic that we had started the year with. The first topic before decimals, which was concepts with whole numbers, which will be discussed at the April 21st Homeschool Connection Night. So place value of decimals, basically what they need to know is that a decimal is part of a whole, which is the same definition as a fraction. So fractions and decimals are very much linked. I like to have them work with fractions. I said think of it like money. Decimals, it's even easier to think about it with money because $1.25 is represented as 1.25. So there's decimal right there. They don't realize how often they do see decimals in life even before they get to 4th grade. Initially, a couple years ago, 3rd grade was when they had introduced decimals, and then when they revamped the standards in 2008, 2009, they changed it to 4th grade is the first time that they see decimals, so they don't have the early exposure like they used to a couple years back. But still, decimals is a concept that they, once I point out how often they've seen it in their life before they actually get to it in an academic setting, they realize it's probably not that hard. So I'll explain this in a second, but tenths is represented as 0.1 or 0.2 if you have 2 tenths, so have you. And it just takes 10 of them to make one whole. So I tell them to think of a tenth as a dime. It takes 10 dimes to make $1. That's a really easy way to think of that. For hundredths, that is 0.01, and it takes 100 of them to make one whole. So I tell them to think of them as penny because it takes 100 pennies to make $1. So tenths and hundredths, as long as they kind of relate those to money, it's kind of an easy way for them to remember. For thousandths, that is 0.001, and it takes 1,000 of them to make a whole. It's no real coin that I can relate that to because that's not how our money system's based, but that's pretty straightforward. The way I have them to represent decimals, if the number is here and it says 4.1, what I've trained them to do, as soon as they see a decimal, they need to put a 1 directly under the decimal point and then a 0, because then underneath it technically has a 10. So then they will see the 4. They know when they see a decimal, they always have to say and. Then they'll see 1, and then underneath they'll see the 10. I was a little hesitant at doing this at first because then I thought they'd see that there's a 4.1 and there's a 10 underneath and try to add them. They don't do that at all. They are very good at recognizing that that 10 just helps them to identify the decimal. So it just says 4 and 1/10. So then if they have That's why I was afraid of that happening when I was making this. All right, so if they have 4.13, they just had another 0 underneath, and you see now they have a 100, so it's 4 1300ths. And then the final one, which is the trickiest one for them, is when they have 3 digits. So 4.135 is, they would now have a 1,000 underneath. So it'd be 4 135 thousandths. It's kind of an awkward way to say that, 4 135 thousandths, because you're saying 100 and then you're saying thousandths. The thousandths is where they get tripped up most. And I'll talk about other common more mistakes later on. So there are 4 ways that they will need to be able to represent, read, identify fractions, or excuse me, decimals. As you can see, I get them mixed up because they're very much related. So the first way is just standard form. That's when they see it in numbers, and they just need to be able to know what that means. So for instance, that says 4 and 135 thousandths. So the test question might say, here's a decimal in standard form. What is it in written form? And so that's standard form. They just need to know that it's written as numbers. So written form is when it gives it to them in word form. They'll see it either in called written form or word form. And basically, it's just the letters that represent the numbers. Expanded form, the SOL framework, when I was looking at it, had talked about expanded form. Truth be told, in benchmarks, SOLs, any tests we've given, I've never actually seen them do expanded form for decimals. They do it for whole numbers. It's still good to know how to do it because they do. It's the same concept for whole numbers, but basically it's just how many there are times the place value plus however many there are times the place value plus however many there are times the place value plus however many there are times the place value. So we see we have 4 1, we have 1/10, 3 hundredths, and 5 thousandths. Like I said, they're going to see that a lot with whole numbers, and we'll kind of talk on that the next time when we get to the whole numbers. They're not going to see that as much for decimals. The one that they will probably see most frequently is the picture models at the bottom. The picture models, what's going to confuse them most is going to be what counts as one whole. If this long strip counts as one whole, then each little square within the long strip counts as 1/10 because it takes 10 little squares to make the one whole strip. But then occasionally they will see, I call this one a grid. They will see 100 of them. So a whole row now counts as a 10th, and each little box counts as 100th. So they have to really identify what is called as one whole, and on the SOL and the benchmark any test, it will say this represents one whole, and it will just have one of these. Then it'll have it'll say, well, I'll show you on a test question. It'll say how many is shaded in on this. So they need to realize that if it's a strip like this, basically they need to count how many little boxes are within it and then figure it out. So they're going to see one both equally as likely, so throwing some probability from the last time, but they just need to make sure that they are transferring that little box doesn't always equal a 10th. Little box doesn't always equal 100. It's going to depend a lot on what is the one whole. So a couple of different ways they're going to see decimals on the SOL. These are kind of just overall general perspectives. First one, if we look in the upper left, the backmost example says which digit is in the 10th place in this number. So this is where it comes very useful to, as soon as they see that decimal, they put the 1 under the decimal point, the 0, the 0, and the 0. Then they have to just look where the 10 is, look directly above it. They see the 8 is in the 10th place, so then they choose that. Really foolproof. Generally speaking, not going to screw that up that often. Other way that it could be represented, very similar. Rather than saying what digit, it could say what is the value of the 8. So then they'd have to say 8/10. Same thing. They still need to put the 1 and the 0 and the 0 and the 0 underneath just to figure out exactly what it is. But generally speaking, that's not where they make their mistakes. This here, I call it place value chart because they're going to see it 2 different ways. Occasionally, it's a little blurry here, but you see it says identify the place value for each digit in the number 3,645 and 27 hundredths. So they have the digits all mixed up within the number, and then they have them listed 2 through 7 there. Then here, this is one of those technology enhanced items I keep talking about, where it's not just multiple choice answers, they actually have to drag things around. So they would have to see the 2 is in the 10th place, drag it there. The 3 is in the hundredths place, drag it there. The 4 is in the 10th place, drag it there. 5 in the ones place, drag it there. 6 is in the hundreds place, drag it there. And the 7 is in the hundredths place. You see there are 6 spaces and 7 choices, so they're going to have to recognize that 1 is going to be left over. In this case, thousandths is not used at all. I can entirely see why they included thousandths though, because there's the thousands place, the whole number, thousandths. That would be just a careless mistake they would make, not quite looking at the TH at the end, because while they are basically very similar words, very different. I'd rather have $1,000 than 1/1000th of a dollar. It's a big difference there. So that is place value chart. The other way they might see it is rather than having the place value, it will have the digit and it'll say value. So for the 2, where's the 2? It would over here it would say you'd have to type in like 0.2, and for the 3, you'd have to put 3,000. So they'll see the value chart. Sometimes the place value chart is going to be the way they're going to see it by and large, and that's going to repeat itself for whole numbers when we get there 2 weeks from now. The bottommost one, the hell is 2.32 written in words. I read that incorrectly. That's how the students have a tendency of reading, because honestly speaking, that's how I read my decimals most of the time. I see it 2.32, but really it's supposed to be read 2 and 32 hundredths. This is where it become very helpful that they put the 1 under the decimal, the 0, 0, because then all they have to see is 2, decimal always means and, 32 and 32 hundredths. So underneath writing it underneath is going to be their big lifesaver with any concept about place value with decimals. Finally, the last example I have here is kind of what I was talking about, very similar to, rather than having a bar, this time it's a circle, and you see it says model 1 is shaded to represent 1 hole. So it shows that that's 1 hole. It could show the grid, it could show the long bar, but it's always going to give them exactly what is 1 hole. Initially, when I believe it was last year, my first year, the benchmark for Warren County didn't have that shaded to represent 1 hole. So technically, the students could kind of make a case to argue what it was. So we said the decimal is going to have it there. We should have it on there. So we have gotten that change in Warren County. So that's going to prepare them even more for the as well as we come to it. So they see there are 10 pieces of the pizza, if you will. So they know that each one is worth 1/10. The big difference between fractions and decimals is decimals are based on groups of 10, the way we learn them at least, and the fractions can be based on groups of anything, anywhere from groups of 2 all the way up to groups of 10. So if it says, might say fraction here, but they just realize fraction and decimals are related. So if it says decimal, it's going to be based in a group of 10, most likely. So that model 2 here, it says I believe there are 7 of them shaded in. So you see that the answers are 1.7. The way that they have that as a bad answer is 1.7 would be including model 1 and model 2, because there's 1 hole shaded in here and then 7/10 shaded in here, but it's only asking about model 2. 1.3 is including the model 1 and the unshaded part of model 2. 0.7 is the correct answer, 7/10. And 3/10 is the incorrect answer, that's the unshaded part. The other way that they might also see it is 0.07, because that would be 7/100ths. So they might try to trip them up by saying, well, there's a 7 and I know that there's supposed to be a 0 in there, so they would try to trip them up that way. One way that the thing that they mix up the most is if they have a grid here. They have to remember that a small little box within the grid is a 100th, and a large, the whole row is a 10th. So they might see that there is 6 of the little boxes shaded in, and so they might write it like this. They see 6 little boxes, and they know it's a decimal, so they have the 0, they know there's no holes, the decimal point, and they get 6. Where they really should be writing 0.06. While they are very good at getting the habit of when they're given a decimal to make sure they put the 1 and the 0 and the 0 and the 0 underneath, they're not always great at remembering the habit of after they write a decimal themselves to check themselves, they still need to put it under. If they put it under, they'll see that they don't have 6/10, or even they can put a 0 underneath, and they can see that there aren't 60 little boxes shaded in. If they put it in here, they see, yes, there are 6 of the 100 little boxes shaded in. So really stressing that at home, to even after it's great to, when the decimal is produced or given for you, to put the decimal in, but it's equally as important when you produce the decimal yourself that you need to put in the 1000 afterwards to make sure that you're checking yourself. So the next thing with rounding is, the next thing with decimals is rounding. And before we get started, we recorded a little video in the beginning of the year about rounding, so I'm just gonna kind of play that for you guys, or not. There we go. Some of your students need a little work on rhythm, as you can see if you watch that. You can see some students, when I watched it the first time, I was laughing because I had some students who were doing perfectly, and then I had some students who were like, so, but even if they didn't have the rhythm, by and large, for when we were working on rounding, they remembered it really well. The rules for rounding are going to follow the same for decimals as whole numbers. I keep referencing whole numbers, which we'll get into next 2 weeks from now. And so the steps for rounding is find your place, which is if it says round to the nearest tenth, all they do is they underline the tenth place. Look next door, that means just look to the right. So I have them circle it. Other teachers kind of sometimes reverse those steps. Mrs. Burke next door, she has them circle the place and underline. It's basically the same thing. I just have them underline and circle. I don't really know why we do that differently, but it doesn't really make a difference. So 5 or above, they need to give it a shove. That means that if it's a number 5 or above, push it, the number that's underlined to the next digit. If it's 4 or below, you're good to go, which means they don't have to do anything to that number. So all digits in the front of the number that's underlined stay the same. They don't have to do anything, just drop it straight down. All digits, including the circle number and behind, all become zeros. In the case of decimals, they can even drop off those zeros because those zeros have no value. They don't have to. I know in 5th grade they do have to, but at this point I don't really care if they drop them off or not. So basically that's how that works. So I'm going to go quickly model one on the smart board if there are, or maybe not. There we go. All right. So for instance, if I have 5 and 183 thousandths, and I wanted that rounded to, that should say hundreds because you can't round to the thousands. If you are rounding to the hundredths, pretend that says hundredths. All right, if you're rounding to the hundredths, first step, who remembers what the first step was? This is how I feel on a daily basis. First step was find your place. So the hundredths place, they would take this, they would write 100, they see it, they underline. Who remembers the second step? Look next door, there we go. So it's 5 or above, give it a shove, or 4 below, you're good to go. It's 4 below, so the 8, you don't do anything to that, you just drop that straight down. Digits to the front, stay the same. Digits behind, 0 is your name. So it's really just that easy, as long as they can remember that rhyme. And the 5 are above and the 4 below, pretty straightforward, as long as they put in the 100 or the 1000 or the 10, whatever it is. Pretty straightforward. Generally speaking, not a huge problem with rounding. They've been doing rounding since, I don't know, 1st grade with whole numbers. The biggest detriment that they're going to have here is not quite understanding which whole number place to actually round to. So the concept of rounding itself is not necessarily the issue with decimals. It's identifying the decimal, which place value they are supposed to round to. So if we go back to our presentation. So a couple of different ways they're going to see this. I personally love this question because it forces them, it says which decimal when rounded to the nearest hundredth is equal to 5 and 59 hundredths. What that means that they have to do is round all of those numbers and then choose it. So not only are they rounding once in the problem, they're going to have to round 4 times. I should rephrase that. They are supposed to round 4 times. Some students choose that they look at it and try to round it just once, but they need to really get in the habit of trying to work on every single one. So first step, they would have to identify the first, the hundredths place and underline it. And so when they underline the 9, they look next door, they circle the 5, and they realize that a 9, when you bump it up, it becomes a 10. That kind of becomes an issue for them. So I told them that, so for instance, if we have, what's that right here, 7, all right, 7, all right. So they would have to find their place, look next door. The 5 basically gives the 9 a shove, which when you shove that, it would become a 10. So that doesn't work quite right. So what I tell them when they have a 9 underlined, they really actually, they actually should box the whole thing because the 5 is talking to the 59 at that point. It's not talking to just the 9. So they know that the 5 is counting to 59, they become a 60. Digits to the front stay the same, digits behind, 0 is your name. The bumping the 9 up, that does give them a little bit of difficulty with not just decimals, but whole numbers as well. That's when I tell them, if you have a 9 underline, just go ahead and turn that into a box and think of it as a 59, a 19, a 29 instead of just a 9, because then they'll try to squeeze a 10 in there. They do realize that the next number after 9 is 10, but they just they might not necessarily just have the number sense to bump the next digit up as well, rather than just make it a 10. So that's why I get them in the habit of, with a 9, to box the whole number. So that's why I love that question. It's going to force them to round 4 times to make sure that each one, even though B is going to work out to be correct, I tell them, I don't care if you found the answer on A, prove your work on all of them. It becomes a little exhausting for them to show their work on every single one, but it's kind of the reality of what they're going to have to do on the answer wall. So that's why we kind of try to instill that early. Next one here, it says, what is 82 and 591 thousandths rounded to the nearest whole number? Rounded to the nearest whole number simply means rounded to the ones place. So in this case, the 2 is in the ones place. That is one thing that will screw them up by and large, is round to the nearest whole number, because round to the nearest whole number, that's not saying round to a specific place. It's just saying to the nearest whole number. They have to realize that anything immediately to the left of the decimal, I have left and right sometimes, is considered a whole number, so they just need to round to the ones place. So again, they would underline the 2, look next door, circle the 5, see the 5 tells the 2 to bump up to a 3, digits in the front stay the same, digits behind, 0 is your name. See 83 is there, it's not 83.000. Could be, it's the exact same thing as 83 without all those zeros, but any 0 after the last digit in a decimal has no value. I always tell them that you could have 7.31 and 100 zeros afterwards, and it's exactly the same thing as 7.31 with no zeros, because zeros with decimals basically mean nothing. But yeah. So the next thing with decimals is comparing and ordering them. So comparing basically means figuring out which number is bigger, and ordering means putting them in order from least to greatest or greatest to least. We kind of touched on this a little bit when we did fractions, because they had to compare fractions. They also had to order fractions. We will touch on this again in 2 weeks when we do whole numbers, because they will need to compare whole numbers. They will need to order whole numbers. So what I tell them to do is to line up the decimal. What I mean by that is physically rewrite the numbers. So 4.1 is there and 4.009 is underneath. They need to line up the decimal point as opposed to line up the digits, because if we lined up 4.1 with 4.009, we line them up perfectly. The 9 would be under the 1, the 0, and then the decimal point would be here and here. They need to get in the habit of lining up the decimal rather than line up just the numbers, which kind of initially kind of messes with them, because prior to coming to 4th grade, they are supposed to line up the numbers, pretty normally. But then once we get to decimals in 4th grade, we throw in that, well, you don't need to line up the numbers normally. You need to line up the actual values. So I have them just line up the decimal. They stack them on top of each other. I tell them, again, referring back to the fact that you can put as many zeros after the final digit in decimal. I have them put in this 0, so then they have the equal amount of places. So we see initially that only had 2 place values. This says 4. I just have them put in 2 more place values, so it lets them compare. So then I have them starting from left, working right to compare each number. They're looking at the place values. So they circle the 4 and the 4, see 4 and 4 is equal. So then they can move to the next one. They circle the 1 and the 0, and they see that the 1 is bigger. So they don't even need to go any further than that, because once you find a number that's bigger than the other, that number is bigger in general. We'll do the same exact procedure when we get to whole numbers too. So they can stop there, put in their greater than sign, and it's as simple as that. Biggest mistake they're going to make here is not lining up the decimal and just lining up the digits. That's not what I want. All right. So to model this, so in this example, they do happen to have equal place values, but just for comparison's sake, I'm going to go ahead and get rid of one of those. All right. So the first one, I would literally take the first number, just bring it down here, 8.71. I take the number, 8 point, to make sure I'm lining up the place values, 0.099. I see that this one does not have equal amount of place values, so I put them in like that. Circle, the 8s are the same, so I move on. 7 is bigger than 0, so then all I have to do is put it in order like that. One thing they will get very hung up on is the fact that this has 2 9s, and they know that 9 is a bigger, initially, they don't do this anymore, I kind of use it as a way to engage them. They'll do it like this, I'll be like, well class, this one has 2 9s, and that one only has a 1. 9 is bigger than 1. And they're like, no, Mr. B, you're wrong. They love telling me I'm wrong. And so then they say, yes, but the 7, and so they do a pretty good job of explaining that at this point. At first, they kind of see that the 9, kind of look at it, they go a little wild that there's multiple 9s and that. Sometimes I'll put it like 8.1 and then 7.999, so they see a bunch of 9s. But if they line up correctly, they see that the 8 is bigger than the 7 from the start. So that's why we do that. So to practice ordering, same thing applies. So in this case, they're going from least to greatest. So they do 2.3, 2.01, 2.009. Now we see these are all missing zeros, so I just go ahead and fill in those zeros so they all are all equivalent amount of place values. I look 2, 2, and 2, all the same, so now I need to look over. So 3, 0, and 0. So we see 3 is the biggest. Because we're going least to greatest, we know that this is going to be at the bottom because that's the only one that didn't fit with the others. So you kind of work backwards here a little bit. So I'm going to cross that one off. So then I look at here, I see 1 and 0. 1 is obviously bigger than 0. So we do the next one, 2.01. Cross that off, and that leaves me with only 2.009. So that actually just happened to be reversed when I typed that up. So that's how that works. As long as they're putting the zeros lining the decimal rather than lining up the digits, pretty straightforward. You'll notice over here I had the additional zeros. Down here I didn't. The only reason I do that is if the decimal is not going to get them answered with all the additional zeros in. So I tell them when they're writing their final answer, write it how it was given to you. Just like when we were talking about ordering fractions, they might put them into a bunch of equivalent fractions. But then when they put in their final answer, it needs to be the original given fractions. They should always put their answer in whatever is provided to them initially. All right. So decimals example for comparing and ordering. I'll be perfectly honest with you, I actually absolutely hate questions like this because it provides them a chart, but then down here, it provides them all the numbers in the chart anyways. If they're going to provide them with a chart, in my mind, they should say which of the statement is true. Like Joel ran more than Justin or something like that. But if they're going to give them the chart with the numbers and then just give them the numbers down here, in my mind, why give them a chart? That's just honestly giving them overwhelming them with more information. I would rather them look at the chart and down here have statements and words like what I just said. Joel ran more than Justin. Justin ran more than Maria. So then they actually have to look back at the chart and come up with their comparisons. In my mind, I don't see a reason for a chart in here, but if they had it with words, I think that would be a great way to kind of tie 2 different things together. So here, they just have to check if these comparisons are true just by stacking the place values, doing the circles, seeing if it's true. If it's true, cool, check all 4 before they move on. Over here is going to be a technology enhanced item where they're going to have to actually drag and drop all of them. So it gives them the 4 decimal and whole numbers down there. They would have to stack them with the line at the decimal, and then so on and so forth, and making sure that they, big mistake here, they might find it in the correct order, but in their correct order, they were finding greatest to least rather than least to greatest. They need to make sure that they were always looking in what order that they wanted in. So common mistakes with all that stuff I just talked about, place value, rounding, comparing, ordering, that's the whole decimal standard. Biggest common mistake is going to be identifying the place value wrong. That's not putting the 1,000 underneath the decimal and then the zeros. Quite frankly, as long as they put that 1,000 underneath every single time they see a decimal, really no reason they shouldn't be able to get it right, because it's a really easy visual way to see exactly what is there. So if they're not putting the 1,000 underneath, they just don't feel like doing it, and essentially they're just kind of slacking off a little bit there. So as long as they're doing that, no reason for that to be the most common mistake. Counting wrong. What I mean by that is if we were to go back to the grid, they might have 7 little boxes shaded in, but maybe they count 6 just because they're counting quickly. So that's what I mean that. Or on the flip side, counting 6 little boxes and thinking that means 0.6 rather than 0.06. So that's what I mean by counting wrong. Mixing up the models into decimals, kind of going back with what I just said. They might see that in one problem it might be that the strip is the 1 hole, and the next problem is the grid is the 1 hole. So they got to make sure they're transitioning back and forth between that. Rounding to the wrong place, maybe it says round to the 100th, but they round to the 10th, or vice versa. Or again, like I said, round to the nearest whole number. Sometimes they have an issue with that. Or not rounding all the choices. If we go back to that question where it said which of the following would round, maybe they round the first one and they think they rounded it right, or maybe they happen to make a rounding mistake. If they would have rounded all 4, they would have seen maybe 2 of them rounded, so then we would have to go back and check both. So making sure that they're always checking every answer. Not lining up the decimals correctly, at this point in the year they don't really have a huge issue with that, because I really drilled it in their heads. When you see decimal, you're going to put the 1000 under it, and you're also going to line it up with whatever happens to be on the page. And now putting in the extra zeros. The extra zeros are really just going to help them kind of visualize, see that, oh, this might have more digits, but that doesn't necessarily mean that it's worth more. So there are a couple of different ways to practice. There is IXLU. That is going to cover everything I just talked about, comparing, ordering, rounding. It's going to give them models, and it's going to say what decimal is this. Pretty much anything, more exhaustive list of decimals than I could give you in the past 40 minutes. IXLU is going to be very good for this. There's a YouTube video I created. It's called Decimal Shop. I'm not playing it here because it's embarrassing for me, but it is on my YouTube channel. Feel free to go watch it out. But we will not be watching it here. The next fun hands-on way to do it is with an egg carton. You can do it with a normal egg carton. We do it with these big ones up here. Let's see if I have one actually set up. Perfect. All right. That's not right. All right. That's not right. All right. This is good. All right. So if you're doing it with a little egg carton, you can just take count from the right. Just take a Sharpie and color this one in, so that will act as the decimal point. Get some number tiles, make them out of syrup box, or you can just get the plastic ones. Drop a couple in and say, what decimal did I just write down? Have them copy it down on paper and actually put in the 1000. And then you can even take it a step further, and you can say round to the nearest whole number, round to the nearest 10, something like that. This is a really good, easy way. You can keep this in your car. Just put all the number tiles in here, fold it up, keep it in your car when you're on a long road trip, have them pull this out. I eat a lot of eggs, so I get eggs in like pallets pretty much. So what I did here was this will come back when we talk about adding and subtracting decimals. So here you see I purposely didn't line up the decimal places. So I put the number tiles in. The numbers just mean where they're supposed to put number tiles. So it doesn't really mean 123 and 6.7. It actually just means put 1 tile, 2 tile, 3, 4, so on and so forth. And then they have to copy this down and then line up the decimal point their way. So if you eat a lot of eggs, or plenty, I'm always going to share. This is a good way to, when we get to adding and subtracting decimals, which is going to be the next thing, just kind of helping them to see that, oh, it's not lined up when they write it down. They're actually going to have to line it up. Poker chips is going to be another good way to practice order comparing. When I was talking about the fractions, I advised you to go to the dollar store and get a cheap set of poker chips. And I said on one side.
Where did you get that again? Because I went to Walmart, I couldn't find those.
Honestly, I got these so many years ago, but I think I got them at the dollar store, just like in the game section. You can probably go on Amazon and get a pretty cheap set. But I got these many, many years. Obviously, I wouldn't recommend going out and getting like the top of the line ones, because those are going to get expensive pretty quickly. Or you can use those and then get more money and then buy cheaper ones. But yeah, dollar store has them sometimes. You can even just make poker chips. Just get a cardboard box and just cut them into a bunch of circles. This just saves the trouble of having to cut a bunch of things into circles. Yeah. So on one side, like I said last time, I just had written a bunch of different fractions. on the flip side, I have a bunch of different decimals. So then I just tell the students, if I want them to compare, I'll just tell them to pick out 2 of them, lay them down. They have to, put them side by side, and then they compare, they line them up. Or if I want them to order, I'll tell them to pick one of each color, and then they have to line them up that way. It's going to work for whole numbers and decimals because they do still need to order the whole numbers before they even get to the decimals. You could even make a set that's ordering just whole numbers, and then a set that's ordering only decimals. Just go out with it. Really taking Sharpie and writing on them doesn't really take that long, especially if a student gets done with morning work early and you just hand them a stack of poker chips and say, number these for me. That's how I get a lot of this stuff done. So those are a couple of quick, easy, fun ways. They have done the poker chips and they've done the egg cartons in school. I seem to like it's a little, they're basically doing the same thing that they would do in a worksheet, but it's just a little bit more hands-on, a little bit more fun and engaging for them. So the next thing, the other part of decimals, other than understanding the whole thing about the place value about decimals, are adding and subtracting decimals. A couple of steps here. Very similar steps to comparing and ordering. First thing, they're going to need to line up the decimal. I tell them pretty much anytime that you see a decimal and then another decimal or multiple decimals in one problem, you're most likely going to have to line those decimals up. They stack them on top of each other. You see the first 3 steps are exactly the same steps to comparing and ordering. They need to put in the zeros to make sure that they're equivalent. Then they need to add or subtract. And then the final step, which I would say is probably the most important step, is to check it with the reverse operation. So what I mean by that is here, the initial problem was given as a subtraction problem. To check with the opposite operation would be to check with addition. So they did the problem here, then they just take the bottom 2 numbers, drag them over here, and then just add them. If all 3 numbers here match with all 3 numbers here, they know they're correct. If something doesn't match, they get something here that doesn't match over there, that means they made a mistake here. Or they made a mistake here, but they made a mistake somewhere, and they need to go back and redo it. They are really good at getting the habit of actually setting up the 2 problems, but I've been working sometimes in small groups where they don't match, and they're like, oh, it doesn't match with my next one. I'm like, no, this is your next one. So they have to actually, get in the habit of, if it doesn't match, and all of you who have just left, your child has done it at some point, not religiously, but a couple times. So they just need to check with that. They will also have word problems that will, the word problems, and I'll kind of delve into the word problems a little bit more, the mechanics behind the word problems with the whole numbers, because whole numbers I can kind of shoot through a little bit quicker than decimals, and I want to make sure I have plenty of time to talk about the benchmark. But word problems, it'll say, like, I think I actually have an example of it. I'm going to go ahead and model one of these on a smartboard for you. I think it's set up. All right, so there they are given 5.6 minus 2.178. I keep getting in the habit of saying point. I'm really supposed to be reading them like a real decimal, but I don't really actually do that. I do that with the students. I don't do that in real personal life. So the 5 and 6/10 is there. They subtract the 2 and 178 thousandths is there. They see that there are some gaps there, so they would need to fill in the zeros and subtract. So I say, this is a fun way to do this again. I say, oh, I can't take 8 from 0, so I'll just take 0 from 8, and I'll just turn it around. They're really good at picking up on when I do that wrong, which I hope transfers over when they do it wrong. Sometimes they by this point in the year, they've generally gotten pretty good at that. Occasionally, I'll talk about one common mistakes is they'll flip this problem, and they'll put the 5 or the 2 up on top and the 5 below, and they'll subtract beautifully across, and then they'll get there and they'll be like, well, must be, I can't take 5 from 2. Where am I going to borrow from? So you made a mistake somewhere then. So I try to encourage them to find their mistake, realize that they put it in backwards. That's going to, generally speaking, when it's given a raw problem like that, they're not going to transpose where the numbers are supposed to be, but it's going to be more in a word problem. So can't take 8 from 0, so they have to go next door. It's called borrowing, exchanging. They call it a new thing like every 5 years. Basically, I tell them just keep going next door until you can borrow a cup of sugar from your neighbor. So over here, they get the 5, which makes that one 10. And over there, 9. 3rd grade, younger grades do a really good job of introducing how that number system works, why they can. It is very important for them to understand the number system, why that works. this point in 4th grade, we have a lot more stuff to worry about that I tell them basically just do the operation. But, conference with them to make sure they understand why that works. But we don't spend a whole lot of time on the subtracting the whole numbers because that's a skill that should have been covered in younger grades. So it is 10 minus 8 is 2, 2, 4, drop the decimal straight down, and 3. So a lot of the times when I'm modeling this to them, I'll say, am I done? And they'll say, no, Mr. B, you didn't remember the most important step. And I said, well, what's the most important step? And they say, I have to check it. So I just tell them to take the bottom 2 numbers and just set it up as a reverse problem. So this is subtraction, so it needs to be addition. So it would be 2.178.
178.
Oh yeah, 178. Be helpful if you write down the numbers correctly. Plus 3.422, and then 0, 0, 6 point. When I tell them go back and check. So the 5.6 matches with the 5.6. The 3.4 matches with the 3.4. And the 2.1 matches with the 2.1. If they have all 6 check marks, awesome. If they don't have all 6 check marks, they need to go back and fix it. Occasionally, if it's a multi-step problem, I'll talk about this more in 2 weeks, they will have to check multiple times because you can't subtract, 3 if it's against an amount, and then it says like he bought this much and he bought this much. You can't take like $20 and subtract from $20 and then subtract again. So they're going to have to do, well, you can do that, but you can't do it all in one step. So they have to, they'll have to check multiple times. That's where it gets a little hairy sometimes in making sure that they check all their operations. But if they do an addition problem first, then a subtraction, and then take the sum of how much they spent away from the total, and I have an example that's going to model that, then it makes it a little bit easier for them. So, all right, so a couple of different examples, how they're going to see adding and subtracting fractions, or decimals. These top 2, those are just, raw problems. That's one's, I believe, an addition problem. That one's a subtraction problem. That one, equal place values that one's not going to trip them up too much. They literally just have to line up the place values. Here, they would have to put in an additional 0 after the 8 once they line it up horizontally, or that is horizontally, vertically. Sometimes they will look at that and try to do it horizontally, and some students are pretty decent at looking at things horizontally. I mean, I can, for the most part, kind of look at things and add them up horizontally. I like to get them in the habit of vertically because it helps them visualize it a little bit more. Down here, this is a word problem, obviously, because there are words and it is a math problem. It says one would drink 1.09 liters of juice. Side note here, a lot of students, when we're doing this, they ask me what a liter of juice is. So it doesn't even matter. She drinks 1.9 cups of juice. I don't care. Change it to something that makes sense. And the fact that they use Wilma, that's going to be a common thing you're going to hear all over. I would love for them to just, because a lot of times the students will see these names that are, common names or different things. It just throws them off. Just use like Mr. A, Mr. B. Probably not Mr. B, because then they'd be like, Mr. B, you're in this problem. So, yeah, but I digress. So it says Richard drinks 0.0 and 987,000 liter of juice. How much more juice does Wilma drink than Richard? So how much more needs to be a clue word to them? That means you're going to have to do a subtraction problem. So they would have to know 1.09 liters of juice and the Richard's amount, subtract those, check those, and then over here. You will see all the answers here. I believe that one's the correct answer. That one would be if they didn't borrow correctly. That one would be if they added and didn't borrow correctly, and that's if they added and borrowed correctly. So you can see all 4 answers are obtained in some way. Obviously, A is being the correct answer. B is if they subtract without borrowing correctly. C is an addition problem, and D is an addition problem. So the SOL will give them 4 answers that they could obtain. It's not going to say like some obscure thing like 1,000 liters of juice. It's going to give them things that are reasonable and they could actually get to. Down here, this is the one I was just talking about, where they might give them an amount. They bought a couple of different items, so this would be a multi-step problem. It says Lenny bought pair of sunglasses for 335 and a beach towel for 871, including tax. He gave the clerk $15 to pay for these items. What is the amount of change Lenny should receive? So there are a couple of different ways they could solve this problem. First, they could take the 15 and the 335, subtract those, and then from that total, or difference, I guess, subtract the 871. So then, no matter which way they solve this, they're going to have multiple problems that they had to check. So they would have to check the 15 minus 335 with whatever that is plus 335, and then they would have to subtract again. The way I would recommend I'm doing is add the total amount of items, because if you really think about it, when you go to a grocery store, which is going to be actually one of the ways I suggest to practice is, you're not going to say, well, I have $20, I'll pay this item, I'll pay this item, I'll pay this item. You'll say, what's the total sum of the total that I'm going to pay, and take it out from that. So add up the total amount of items and then subtract it from the 15 and go from there. So then there, again, those answers are all obtained in different ways. I forget which one is the actual answer, to be perfectly honest. But one answer is, what subtraction ones is they didn't borrow correctly. One, and then down here is they just added the 335 and the 871, and they didn't take it a step further and subtract from the 15. And one of them is an addition with a borrowing mistake. So as you can see, they really come up with ways that they could obtain the answer if they're not thinking carefully, not doing all the stuff correctly, not borrowing correctly. So word problems, especially multi-step word problems, are going to be a really good indicator of knowing how well they can read, interpret a math problem, do math operations, and how well they can, understand outside of the box thinking. So common mistake is going to be, number one, not lining up the decimal. Again, going back to comparing and ordering, they need to really get in that habit of lining up the decimal. Addition and subtraction mistakes, that's, like I said, not putting in larger number on top in subtraction, or subtracting across zero really messes with their minds, which is a skill that is introduced in younger grades and should have been mastered by this point. But subtracting is across zeros, or not borrowing correctly, or maybe like they go next door to borrow from the 5, and rather than making it a 4, they make it a 6 for some reason. They know that something has to be taken and something has to be given, but it kind of messes with their mind a little bit. So addition and subtraction as much as possible, in addition to multiplication and subtraction. Basically, the basic operations are really the foundation for everything in math. So it's going to be very important that they're strong in all their computation. Not checking their work, because even if they make an addition and subtraction mistake, and then they check it, and they don't match up, they know they made a mistake somewhere wrong. Because 9 chances out of 10, if a students are relatively strong in addition, that's the very first computation that they ever learn traditionally. Subtraction, they might have a problem with it. So, like I said, subtracting across zeros or borrowing. But addition, generally speaking, they don't make a whole ton of mistakes on unless they forget to borrow the 1 or whatnot, or carry up the 1. But if they check it, that's really a foolproof way of figuring out if they made a mistake. Because if something doesn't match up, they know they went wrong somewhere. The only big drawback is if they are poor in both addition and subtraction. It's quite possible that they could check it wrong, like do the problem wrong and then check it wrong and match up that way. Generally speaking, I haven't seen that happen a whole lot. Like if they're checking correctly, generally they're going to find their mistake that way. They just really need to go in the habit of, if they check it and something doesn't match up, they actually need to go back and fix it. They can't just accept that it's wrong and move on. They need to make sure that they actually fix it. And not interpreting the word problems correctly, that's not knowing if they're supposed to add, subtract, if it's a multiple step problem, if it's a single step problem, all those kind of things. Like I said, I will get into word problems pretty intensely 2 weeks from now when we're doing word problems, because whole numbers, because whole numbers, everything that I just did tonight is basically the same thing with whole numbers, just without a decimal point. It's everything they need to do with decimals, they need to do with whole numbers. So like comparing and ordering, they're just comparing and ordering the same way. They're going to stack them top to bottom. Same thing with addition, subtraction. They're going to line up the place values, all that kind of stuff. So that kind of brings us to our ways to practice. IXLV, which is immediately after you, is going to practice everything with adding and subtracting decimals. It's going to give them pictures. It's going to give them word problems, multi-step word problems, just normal computations to do. So IXLV is going to be very helpful there. Another YouTube video that I'm not playing here because that one's not as embarrassing because Miss Wagner did that one with me. But you can check that one out. That really just drags it into their mind to line the decimal. If coming back to our poker chips, if you using the poker chips, you just can give them, actually make sure they're both on the decimal side. Just give them 2 of these or 2 of them to subtract. Make sure they would, I mean, if you want to really trip them up, give them, you see that one's 0.9 and that one's 2.9. Tell them to them and say subtract these 2. So they would actually have to redo them. Or if you want to go for another bigger challenge, from a fraction, no, don't do that. Give them 3 and say add those up. And then make sure that they are checking as well. You can do this, you can practice this in real life at the store. If you go grocery shopping with your student, bring a clipboard, a little notebook, what have you. And as you're going along, have the students write down what you're buying and how much it costs, and then kind of total it up. And then at the end, say, you need to kind of keep a running tally in your mind too. A ballpark, say maybe you ended up spending, it's somewhere around $60. So you say, well, I'm going to give the clerk $60. How much change am I going to get that? So not only is that going to make sure that they've totaled up the items as they went along, they're going to have to find the change at the end and then check it. If you want to really screw with their mind, throw tax in there too. Which is funny. I didn't know Virginia had tax on food, which Pennsylvania does not. So like
California don't either.
Yeah, the very first time I went grocery shopping when I moved down here 2 years ago, I was looking at my receipt on my way out, and I came back and I was like, you charged me on tax? And they're like, what do you mean? I was like, well, I only bought food. I didn't buy like clothes or anything. And they're like, yes. And I was like, you guys charge me tax down here. Yeah. And so I was like, oh, okay. Well, so now I know. And then my mom's like, yeah, you didn't realize like that? And I was like, well, nobody told me. So yeah, if you really want to take it to the next level, throw in tax. It's going to have multiplying decimals, which isn't something we really did in 4th grade, but they're going to do it in 5th grade. So after they're done with the SOL and they're ready for 5th grade, go ahead and do that over the summer. So the thing that is going to be probably the most important takeaway of tonight, not that the last hour was not important, but let's pretend that didn't happen. Where was I on this? Benchmark is going to be the math benchmark is going to be 1 week from today, next Tuesday, April 14th. The benchmark window closes on April 15th, which means that the students pretty much need to start it and end it on the same day. I will basically block off that entire day for the students. It's reasonable to assume that they can get it done in 1 day. It's going to cover 4 topics. First one is going to be fractions. Ways to practice fractions in the next week. IXL, Q, R, and S. Or review the Homeschool Connection Nights, both the presentations that are available on my website and the YouTube videos, which are available on my YouTube channel. Both ones from February, I think it was like February 10th and February 24th, covered fractions, everything that they're going to need to know about fractions. Watch the YouTube videos with your students. Go through the presentations with them. That is going to be a pretty great resource to go and help them. Geometry, which like they've been doing really, really well with geometry for the most part. We'll be taking just a unit test on that tomorrow. IXLP, which is what they're supposed to be working on next door with Miss Burke. And 3rd grade R7 is going to be ways to practice geometry. Homeschool Connection Night presentations and the YouTube video from March 10th is the stuff that covers geometry. Like I said, watch the YouTube videos with your students. Pretty much everything I told you guys, the students have heard. It's not going to hurt them to refresh it, see it modeled up on the board. But those YouTube videos are going to be a really good resource because if they forget what to do or you forgot what to do, you can always rewind the video and rewatch what I just did. Adding decimals, I don't think there's a whole ton of questions on adding decimals on the benchmark. I just realized when I was looking through it, there are a couple of them. IXLV and tonight's Homeschool Connection Night, what I just modeled to you and what they had seen. It's going to be this. And patterns, which we don't spend a whole lot of time on patterns in 4th grade because they've been working with patterns since preschool, kindergarten. The big thing with patterns is making sure that it might give them the first 4 numbers and says what is the 6th number. So not only do you need to figure out the 5th number, They also need to figure out the 6 number, so just make sure that IXL is going to cover all sorts of different patterns, number patterns, picture patterns. I don't know what those are really called, but so that's going to be cover all of that stuff. But the big thing, make sure that you are preparing your students for the benchmark. There's a whole week, including a weekend. Really make sure geometry, by and large, class has been doing very well with, and it's also freshest in their mind because that's what we're just finishing. Fractions, a lot of them still need a lot of support on fractions, especially on stuff that requires them to convert fractions into like denominators. So LCM, like I said, watch the YouTube videos. I believe there is an audio issue on one of them. Even with the audio issue, the video showed up just fine, so you can still see me working through the steps. You can always send me something, an email, class messenger, and I can do a quick video of modeling something and send the video to you directly. But I really ask you in the next week, spend a lot of quality time with your student, preparing them for the benchmark. While we're on the topic of benchmarks, they're going to take their Virginia Studies benchmark tomorrow. They reviewed yesterday while I was out with the substitutes. The substitutes said they did very well. Today we reviewed, and majority of them did very well. If you have time before they go to bed tonight, if they hop on my website, go to forms and all the way down to Virginia Studies resources, chapters, the benchmarks on covers chapters 6 and 7, the new nation and the Civil War. If they play a round of Jeopardy, either against you or by themselves, each round of Jeopardy will take maybe 15 minutes. That's going to be a really good resource to prepare them for tomorrow. That one will not take them all day. I'm not blocking off the whole day just for that. It'll take them like an hour tops, maybe. Social studies, the students do very well. Friday, this coming Friday, is in April 10th will be the reading benchmark. The reading benchmark is just going to take the place of their normal reading quiz that they take. They asked about today. I think it's like 3 to 4 stories or something like that. It's going to basically take the place of their normal reading quiz. So they kind of didn't have it on Friday to expect some sort of reading assessment. We'll fit the science benchmark in at some point. I haven't quite figured out when that is. I don't like benchmark season. And the writing benchmark, they have like an extended time for the writing benchmark. That one, and I can put that in like 2 weeks after the benchmark window closes. So we'll start on the writing of that tomorrow. We did a cool activity today where for their morning work, I write a detailed description of a step-by-step of how to make a peanut butter and jelly sandwich. And then, so they wrote them, and I collected them, and I went to the cafeteria, and I got bread and peanut butter and jelly, and I read them, and whatever was on the paper is how I made the sandwich. So it started from get bread, get peanut butter, put the peanut butter on the bread, put the jelly in the bread, put it together. So like if this was, the one was pretty good, except for they didn't say anything about putting the bread together. They just said put the sandwich in the bag. So I stuffed bread with jelly and peanut butter without it put together. So like if this was the bread and it said put the peanut butter on the bread, I just took the jar and I just went, and then I tried to put it together. And then there were like, out of the 22 students, there were 2 who were very, very detailed. One just said open the jar, put the knife in the, and that's exactly what I was looking for. Put the knife, the only thing he messed out was he didn't say smear the jar. He just said put the peanut butter on the bread. So I was exaggerating everything. And then one student actually did have it step by step. Like if I would have followed his, I would have had a perfect sandwich. But so anywhere in between. So a lot of detail in the writing. They understood that's why. The one thing that they really liked, you can ask your students about this. The one student said, open the jar, spread the peanut butter on the bread, but didn't say anything about a knife. So I held the bread, I opened the jar, I took my hand and I went, so spread peanut butter, and they got to pick that up. I was like, well, what? The directions didn't say anything about knife. So the thing behind that was to show detail, which is something they need to do in all subject areas. Yeah. So, as usual, very grateful for you guys joining me tonight. It really means a lot that you're coming out here, especially as the weather starts getting nicer. Make sure you're using these strategies with your students. shouldn't say we will be working on these concepts in the upcoming weeks. They've already seen this, so pretty much within the next, by the end of April or beginning of May, we're going to be done with the curriculum, and we'll just move into review to get them ready for June 4th and 5th. Please, like I said, help your child prepare for the benchmark 1 week from today, whole week. Please complete the feedback slip at the end. I look forward to seeing you next time. Next Thursday, not this Thursday, like 2 days from now, but next Thursday is the reading one. Reading one, truth be told, I don't even know what skills we're doing quite yet, because I'm going to base that off of how they do on the benchmark on Friday. So on Friday, they'll take the benchmark, I'll scan the sheets, I'll get a little printout from the website that we do our benchmarks from, and from there I will figure out what skills we're doing and kind of target the skills that the students as a class miss. And then Math Homeschool Connection Night on the 21st is going to be about whole numbers and word problems. Then if we're shooting forward to the next month, May, it's going to be up to my website. If I go to my website, if we're looking forward into May, I pretty much on the classroom calendar. On the classroom calendar, I have all the important dates posted. These are all tentative because something might come up and I might change anything. But in May, on I think that says May 5th, that one is going to be the last traditional Math Homeschool Connection Night. And what I need from you guys is I'll send home a paper with basically all the standards listed of the math standards, and I need you guys to pick like your top 5 that you want reviewed, and I'll kind of structure the night based on that. We will also go over pretty much everything about SOL testing for the math testing. I'll get into more details there. This one, the May, I think that's the 14th. May 14th is going to be the last reading homeschool connection night for the entire year. We'll talk about the SOL there as well. Don't have the skills picked out yet because I like to pick the skills out closer as we get there so I can figure out what the students need to. Down here, these last 2 are big changes. I really encourage you to come out to these ones. The Virginia Studies Homeschool Connection Night is going to be May 19th. Make sure you understood I said Virginia Studies as our social studies curriculum because there is an SOL in that. So that one is going to have to be from 6:30 to 8 because I have to cover 400 years of stuff. Kind of hard to do that in an hour. And that also will give you a week to really help prepare your students for that. And then the final, very final last homeschool connection night is math. That is going to be when your students are invited to come with you. And we'll kind of do a students versus parents kind of thing with math, review all the concepts in math. Your students will go against you, still working on the logistics of that, but to kind of handicap you guys for like multiplication rather than doing like traditional, like you're probably used to. You have to do lattice box, like what they're used to. So I'll kind of handicap that. So that one will be from 6 to 8 because
And what's the date?
May 25th, I believe. No, 28th. This is the classroom calendar is all available on my website. I think it's, I want to say the 28th. Yeah, because that's the 30th.
Still,
I think we'll be out of town.
We will bring the party to you. And the SOL dates, I know it's a little early to start thinking about those, but just so you're aware, as of now, Virginia Studies is scheduled the day after, I won't say that's Memorial Day or Labor Day, I screw those up, which one's which? Memorial Day, maybe? Memorial Day?
Memorial Day.
Okay,
Yep.
it's the day after Memorial Day. In my mind, they're like the same holiday, even though they're not at all.
No.
I don't know why. It's because it's one's like at the end of the school year and the one's at the beginning of the school year. That's where my thought process comes from. I know they're very different. Virginia Studies is then, reading is going to be the same night as the homes, or not the same night. Don't bring your child through SOL with me. Reading SOL is going to be the same day as a student versus parent homeschool connection night. So that might be a really good way for them to, they're probably going to be a little stressed because they have taken 2 within 3 days. It'll be a good way for them to kind of get out some energy, rub your guys' faces in it. And then June 4th is going to be SOL day 1, and June 5th is going to be SOL day 2 for math. We were fortunate enough that we were able to split it over 2 days, which is awesome because then they don't have to take it all in one shot. Fortunately, the state does not allow us to separate the reading into 2 days. They were allowed in third grade, but after third grade, they have to take the reading one day. So, wow, I ran really over. I apologize for that. Do we have any questions? All right, I'm going to go ahead and stop the broadcast. Please, one final thing before I stop the broadcast. On the feedback slip, the one question, the open-ended question says, how do you plan to use these skills at home? I'd really like for you to focus your answer on how you're going to help prepare your student for the benchmark. By next week, within the next week, I'm curious on what I can do to be most effective to help you guys prepare your students. Not that I'm not going to lay it all on you. We are going to review pretty extensively between now and then. But I'd just like to know what exactly you're going to be doing, whatever support you might need. I'm going to go ahead and stop.
What is the feedback?
You go to the last slide. Oh. Go here and